everyone, welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Sachi, who has completed the course ROS Navigation in 5 days. And at the end of this course, there is a project you can present in which you apply autonomous navigation to a real robot here at the construct. So that is what we're going to be seeing here today. So, hello, Sachi, how are you?
I'm good. How are you?
I am great. I'm very excited to see your presentations and your work. So
Yeah.
please, whenever you want, start sharing your screen and show us how you've achieved it.
All right.
Great. I can see your
Yeah.
screen now.
Okay, that's good. So, okay, so this is my ROS entire navigation stack project. So what I have done here is basically, if I give a goal post to the robot, then it will plan a path towards the goal and avoid all the obstacles while it execute the path. And I have also created a navigation stack program that directly interact with the navigation stack for the robot, which like I can send the labels or like I can send a position, goal position, and it can directly go to that goal while it avoids the obstacles.
Mm-hmm.
So let me just go ahead and show you how it works. This takes up a little bit of time.
Mm-hmm.
I will turn on the ROS too. Okay, as you can see, the global cost map has been loaded.
Right.
Yes, so this is just the raw map. It's not a cost map. This is the map that I have generated using the mapping,
Mm-hmm.
SLAM mapping. And this will be my global cost map. And this will be my local cost map. So as you can see, all of the particles are scattered around all over the place, and my local cost map, my scan readings, and my global cost maps are not properly aligning because the AMCL node hasn't received enough information so that it can guess the pose of the robot in the environment.
Uh-huh.
So I have to move a little bit, like give it some 2, 3 spins so that it has enough amount of data to like reposition itself. So as you can see, if I spin, the particles are like getting concentrated at the single
Yeah, yeah.
point.
I think it'll be helpful if you spin the other way as well.
Yeah.
AMCL likes that. Because right now,
Hmm.
seems like it's like 90 degrees still confused, right?
Yeah, it has two possibilities, I guess.
But that should be enough. Maybe we can, at this point, we can maybe send a goal to somewhere and
Yeah.
see what happens.
So I will send a code here. Let's see if it executes.
Yeah, it looks like. Can we look at the camera to see if it's actually moving?
Oh yeah, sure. Let me just do that once more.
Oh yeah, we saw that it moved.
Oh, oops.
You can also give it an initial position.
Um,
Well, I mean, you have to see where it's at.
oh yeah, I think it's near the wall. Okay. Yeah, I think the goal has been reached.
Nice.
Yeah. So this was one of the way to like navigate, and the other way was like directly uh, sending a command to the writing a prompt in the command line, and it will directly execute. Let me just go ahead and show you that. Okay, so if I write corner one and execute, then you
Uh-huh.
can see here it directly plans a path which goes to corner one.
Oh, nice.
So this was the corner one here. So as it reaches, I get a prompt saying goal has been reached, and that's it. So this was my entire project. So let me just go ahead and delve into each and
Oh,
every sections of it.
can we just send a couple more, or is it just
Oh, oh
like
yeah,
one corner? I just want to see
no,
if
no, yeah,
there's.
sure, sure.
So it's the same
Oh,
corner.
okay. Let me just try some different position.
Ah,
Yeah.
I can get through the hard part, which is that middle of the way.
Yeah, that was really tricky to like make it there.
Mm-hmm. All right. Awesome. Awesome. Please now continue. I just wanted to see a couple
Oh,
more spots.
okay. So I will go ahead and start explaining the code.
Yes, please.
So very first section, so basically the navigation stack was divided in three sections. The first one was mapping, the second one was localization, and the third one was path planning system. And the fourth one was the navigation program, which I had like created. I will go ahead and explain every section to you. So starting with mapping. So here I have used slam G mapping to create the map of the entire area. So this was my node configuration. And here I have set the base frame to base link because in my frames, as you can see, all of my components are directly connected to the base link.
Yeah.
So, and if you go ahead and see the base footprint is connected to base link. So I can use either of those and I won't get an issue. So I have set the base frame as a base link, ODOM frame as ODOM. Again, according to the map, my ODOM frame is ODOM. So, and the other parameters that I have changed is maximum U range because it's 5.5, which I'm able to get enough amount of data to create a map. Earlier it was set to 0.5, which was very pretty difficult to create the map of an entire area.
Hmm.
So the rest of the parameters these I haven't changed. I have kept it default. So after this, once the map has been created, I'll just go ahead and show you the map too. Can you see the
Yeah,
map
yeah,
over
we
here?
can see it.
Yeah, it was a PGM map. I had to convert in PNG so that I can like show it to you.
Display. Uh-huh.
Yeah. So this was the map of the area. So it might not look entirely similar because few of the parts are moved, as you can see, like
Yes, yes, all
yeah,
the time. And students
yeah,
will move it around.
yeah. So yeah, it's almost same. And once the map has been created, the map server node, this node is responsible for publishing the map to the map topic and also providing a service to AMCL node so that AMCL node just subscribes to the map, like just gets the map one time.
Uh-huh.
So this was all about the mapping. This was what I have used to create as a generator map. And then moving on to the next section, which is localization. So here I have used AMCL node. So this is my AMCL node configuration. And I have set the scan topic as scan uh, because that's where the scan topics are, like scans are published. Then I have set the map topic to true. Okay, so initially this was set to false. Why I have set it to true, I will get there in coming explanations. So the ODOM model type is differential as we have Turtlebot 3. So the base frame ID is base footprint and the number of particles, the minimum and the maximum particles I have set to 500 and 1000. Initially there were 100 to 200 or 100 to 500, sorry. So that was not enough to get me a accurate position because if I had planned a path, it would execute the path, but in the middle of the like execution, it will lose its position.
Right.
So once I increased this particles, my path planning got a little bit better. Then even this KLDZ, which I had set it to initially 0.80, so which gave me a lot of problems because my robot was not very confident in the pose that it think it is in. So once I like raised it to 0.99, my paths were followed accurately, like without any interruptions or something.
Hmm.
Then the rest of the parameters I haven't changed. I have kept them the same as they are, except the ODOM frame ID, which I have set to ODOM. So this was all about the AMCL node. So once this node activates, as you can see, all the particles were scattered in at the beginning of the like localization. So I had to move the robot a little bit so that I can get enough amount of sensor data so that I get a pose estimate of something like this, all concentrated at the same point. So there was one more thing that we were supposed to do in this section, which was to get the pose. Like if I'm at a certain position, I would run a command in the terminal and I would get a pose. So this was the node name get pose service, which was responsible to get the position, the coordinates of the robot of where is it. So let me just go
Oh.
ahead and show you
Mhm.
the Python script. Yeah. So this was a script for get pose. So basically what it does is it subscribes to the AMCL post topic where the positions are constantly uploaded on this topic, like published on this topic. So it just subscribes it, and once it's subscribed, like I will just trigger this handle get post function. Whenever I will call this service, this function gets triggered. So once this function is triggered, I will just extract the position and the orientation, and I will send a message saying these are my position, these are my
Mm.
orientation, and that's it. Like this is how this part of the code works. But moving on to s- this spot saver node, which is responsible for saving the spot in a specific file. So in a text file, basically. So I'll just go ahead and show you the Python script for this. So again, this node subscribes to the AMCL pose node, and it gives out a service saying /save pod. So whenever I will call this service, this function handle save spot gets triggered. So once this function is triggered, I will just extract all of the pose. This is the pose callback function, by the way. So when I will subscribe the topic, this function gets triggered. So once this function is triggered, I will just store the message that I'm getting from the AMCL pose
Yeah.
topic. So once I have stored the message, then I will just extract it and I will write it in this format so that I can get a structure of something like this,
Uh huh.
like a proper structure for the message format. So this was all about the spots to file, like save, like this extracts the coordinate and saves it in a file.
Uh huh.
So yeah, that's about, yeah, localization part. And yeah, I forgot to say the service. So this was my service format. It just requires a label as an input, and it sends out like navigation is successful.
Right. Like we did, you did the corner and the pedestrian, right?
Yeah, yeah, yeah. So let's move on to the path planning system. So this is like the brains of the navigation stack, I can say, because this is the part where the move base node is basically who is responsible for sending the velocity commands to the robot base, and it also plans the path. It also creates the global cost map and local cost map. So I will go ahead and explain each and everything. So this was my launch file for move base, and this is my node configuration. So there are some bunch of config files that I have loaded along with this node. Uh, the config files are like global cost map, local cost map, and the common cost map parameters for both of them, and the local planner and global planner. So let me just go ahead and show you the first config file, which is a common cost map file. So in this, all of these parameters I have are applied to both of the global and local cost map. So first thing is the robot radius. I've got this robot radius from the Turtlebot navigation package, which was on the GitHub.
Mm-hmm.
So I went ahead and referred to like what they have done. So I got the robot radius as like 0.16. So I
Yeah.
also set it up like that. I set the robot base frame to base footprint, and update publish frequency and tolerance frame I have set according to the like what they have set in the package. Resolution is the same as the map resolution. Then these are the obstacles and ray trace range. I have kept them same. And these are the three layers. Static layer, which will be applied to the global cost map. Obstacle layers. This layer will be applied to local cost map, and inflation layer will apply to local cost map too. So in this obstacle layer, I have said data scans will be from the topic scan. So based on the scan topic, whatever the data it has been received, based on that, the local cost map will be generated. And I have set infinite is valid true, which means if I get a reading which says infinity, that means there is nothing in the path, that there's nothing in that particular beam. So moving on to the global cost map. So here I have set the global frame to map, and rolling window will be false because we don't need rolling window for global cost map. I want the global cost map to be static and just present there.
Right.
So I have uploaded two layers. One is static and the other one is inflation. So as you can see, if I just show you this, yeah, so this light blue like borders that you see, they are inflation. Like these are the inflations.
Right.
So
Of the global cost
yeah,
map. Okay.
yeah. So and the light blue shades that you see around the objects here over here, these are for the local cost map.
Right.
And yeah.
Sorry to interrupt, by the way. You have 5 minutes left.
Oh, okay. So this is the local cost map. I have set the global frame to ODOM, and as you can see, I have uploaded two of the layers, which is obstacle layer and inflation layer. And this is my move based configuration file. I haven't changed anything. I have set it as they have set for the Turtlebot robot. And yeah, that's it. This is the local planner. So as you can see in my cost in my launch file, I've set the base planner to navfan and local planner to DWA local planner.
Mm-hmm.
So these are the configuration files for them. So this file I have gotten from again from the Turtlebot navigation stack GitHub file. So I have tuned some of the parameters like maximum velocity x, goal tolerance, and xy tolerance, and path distance bias because they gave me a kind of better result. Uh, if I had set too tight constraints, then my robot would just stuck in a place. So
Mm-hmm.
like I have tuned them accordingly. So this was all about the path planning section. So let's move on to the final section, which is the navigation, where I have to create the program which directly interacts with the move base node. So this is there were two sections in this. One was the get coordinates part and the send coordinate part. So let me just start with the send coordinate part. So in this, the send coordinate action client is the name of the node, and it requires a label, as you have seen that I get a prompt saying I have to type like a label or a position place.
Mm-hmm.
So it gets that label, and once it get that label, uh, it has been this function is being called send goal. So once this function is called, what I'm trying to do here is like first I will be a proxy client for this service, which is get coordinates. So once I'm allowed to be proxy client, so this service gets activated. So once this service gets activated, I'm calling this function handle service request. So once the handle this function gets triggered. Oh, by the way, I'm also opening a file for spots where I have recorded. As you can see, this was my spots.yml. These are the
Mm-hmm.
spots positions. So yeah, so I will open this file and I will just extract all of the, according to the label that I have received in here, like I am sending the label over here. So based on the label, this service has been called. So according to that, I will extract the position, orientation, and I will send the response in this format so that it's in a proper message format. So why I'm sending this like this? So this was my service structure. So I am using geometry message for sending the position and the orientation so that I'm sending in a correct format. Uh, so this is my service file format. So once I'm done with this, I will get this service will send the response as a position and orientation. So once that is done, I will just extract all of the orientation and the position and update it to the like this is the move based goal message format. So update in that format. Once I've updated, I will be now an action client to the move based server. So once I'm allowed to be an action client to the move based server, I will send the goal. So while I'm sending, I will get a prompt saying send goal. So once the goal has been sent and it's executed, I will get a response as like goal has been reached. As you have seen, like once the robot has reached the position, I had gotten a prompt saying goal has been reached. So yeah, that was all about the ROS navigation stack.
Awesome. And that pretty much covers it, correct?
Yeah,
Awesome. Let me first of all, congratulations, Shachi. So let me give you a round of applause.
thank
Very
you.
very nice project. Very
Hmm.
straightforward and easy to
Hmm.
understand. Uh,
Yeah.
let me mention a couple things I really liked and a couple
Hmm.
comments and one question, two questions. So
All right.
first of all, uh, there's a couple of things that I really liked about your setup.
Mm.
Uh, the first one, the first thing is that uh, great job identifying, for example, the important parameters and separating everything conceptually in terms of
Yeah.
the move base blocks, AMCL, G mapping, and
Yeah.
move base. That's very important because at the end of the day, you're gonna be grabbing from there and just reusing it according to your
Yeah.
needs, and you have
Mm.
to have it really clear, and you've done that. So I really like that. Another thing that I really liked was your three nodes of the application, right? So you did
Yeah.
the get pose node,
Yeah.
the
Yeah.
spot to file node,
Yeah.
and
Yeah.
the client, the move based client, basically.
Yeah.
I really
Yeah.
liked how elegant and short they were, and to the point. And I
Yeah.
can tell you have um, coding experience because of how you wrote them, right? For
Yeah.
example, I really liked how in the uh, client, you just run it once, then
Yeah.
you wait for the input of the string, and then you just run it once instead of leaving a spin. So
Yeah.
that means that you have clear, what you want each node to do, and have all these concepts in your mind of what you can do with the node. So that was really nice, um,
Yeah.
as well. Um, so a couple of comments I
Mm-hmm.
noticed. Um, the first one would be, I mean, just very simple, very, but I noticed, just an advice, I noticed you go into your
Yeah.
workspace, you CD into the
Yeah.
catkin, and then you do the ROS launch. You
Oh
don't
yeah.
have to do that. If you,
I did try doing that, but the thing is, I don't know why, but it's weird.
sometimes it doesn't
If
work,
yeah, it
right?
doesn't work. Yeah.
That means that your workspace, for whatever reason, isn't
Mm-hmm.
sourced in that terminal. So
Oh.
you got to think of like, in a way of like, all right,
Mm-hmm.
once you compile and source the workspace,
Mm-hmm.
it's already in the system. So if you
Yeah.
have to, for example, go into the node location to do a ROS run, otherwise it doesn't work, there's a little bit
Mm-hmm.
missing. It's a luck that it compiled and everything, but there's a little bit extra in terms of sourcing that. So I mean,
Yeah.
that's with practice, and you'll see once you are starting to source different workspace how it can get a little complicated.
Yeah.
So that's why I mention
Mm-hmm.
it. Uh,
Mm-hmm.
just be mindful of that. And then the other thing I wanted to mention, basically, you parsed very well those spots, and then later used them. But
Yeah.
I'm pretty sure you only used string parsing, right? You just used Python to
Yeah.
parse those strings. So one thing
Yeah.
to sort of upgrade it and bring it into ROS is to
Mm-hmm.
simply save that YALM as ROS parameters, right? And then
Oh.
you can load them as parameters
Yeah.
instead of kind of looking for the string match that
Yeah.
you were
Yeah.
doing.
Yeah.
That way,
Yeah.
you'll see. I mean, it's not only strings; you can upload anything
Yeah.
as a ROS parameter. So that way, you'll start practicing and sort of uh, getting into the ROS mindset of of those
Mm.
tools that you can just grab, and it'll make your life easier because you're really good
Yeah.
at that parsing of the string. But what if another type of message that's really difficult, and you
Yeah.
spend an hour trying to process that when you
Yeah.
could
Yeah.
just
Yeah.
upload it as a parameter. So that's
Yeah.
That's the other comment I wanted to make. Oh, and the last one, just a convention and to avoid confusion, I noticed that
Mm,
your inflation radius for your
mm,
global cost map was
yeah.
the same color as your local cost map. Convention
Yeah,
says
yeah.
the
Yeah.
inflation should be, the map. You change the color scheme.
Mm-hmm.
I mean, you can do whatever you want, but it's
Yeah.
easier to recognize with your
Yeah.
vision like that.
Yeah.
And other than that, I mean, it was really, really nice. Really, like I said, really elegant and like
Mm,
condensed to achieve the goal. So I just really want to congratulate you again for a really
thank
nice
you.
job.
Thank you. And I do have one question.
Yes, go
S-
ahead, please. Oh, I
Uh,
actually
s-
have one too. I forgot
oh,
to even. The one question
okay.
I noticed was that
Mhm.
you use base link and base footprint in two different places. What is the difference
Yeah.
between them?
I think the base footprint is like a 2D representation of the robot, and the base link is like the 3D representation of the robot. Like,
Right. Well, usually the base link is the where the
Mhm.
center of mass of the robot is, which can be
Yeah.
off the floor. It can be on the
Yeah.
floor, and the base footprint is that projection of said base link on the floor.
Okay.
Um,
Okay.
and usually, uh, when there's um, since you're in another place remotely,
Mm-hmm.
usually, I mean, since base footprint usually is the first one, that's why you said it on the move base. No other reason, and it would work if you switch it to base link, just to make sure we're
Mm.
arriving to that first TF tree. That's the only difference.
Okay.
But
So
please
like
go ahead.
if like um if the robot, like for my case, the Turtlebot was my robot, so I didn't had an issue if I had set base footprint or base link
No, yeah,
because
yeah.
it was a symmetrical structure.
Mm-hmm, mm-hmm,
So if I
mm-hmm.
had something like a robot or something, maybe I would have gotten some
Maybe it
issues
would
or
crash into
yeah.
the wall a little bit, yeah, because they would not be at this exact same spot. Yeah.
Hmm. Okay, so
And you had a
my
question for
question,
me, yeah.
yeah. So when I was creating global cost map and the local cost map, so as I have shown you in the AMCL node, I had set the map topic to true. So initially that was set to false. When I had set to false, both of the global cost map and the local cost map that was generated were not aligning itself. So all of the maps were scattered, like the main map, the global map, and the cost map, local cost map, all of them were separated, not aligned. After like after like doing some research, I found out the way the move base is receiving the map is different. Like it directly receives the map from the map topic. I discovered this from seeing the ROS navigation stack diagram that you have in that course.
Mm-hmm.
So it was directly receiving it from the map topic, but AMCL node was just subscribe like just receiving the map once through the service from map server.
Yes,
So
it's not continuous, right?
yeah,
And this is a
so
particularity of AMCL. Yeah, I'm sorry,
okay.
of your map server, which provides, because I believe that
Hmm.
your question is why is it that it's just once? Is that your
Okay.
question?
Yeah, yeah,
Yeah, because not sure, but I'm pretty sure that the reason is like you only publish once because
yeah.
it's not good. The first the map isn't gonna change in terms of the
Yeah.
static one that you mapped, and
Hmm.
because of you just don't want to keep pushing useless information. But sometimes it will have a little bit of an issue because it
Hmm.
already
Yeah.
published it, right? And you when you
Yeah.
try to subscribe to it, it won't appear in Arvis, especially Arvis.
Nah.
It might be
Yeah.
that your AMCL already received it, but
Hmm.
since Arvis wasn't open or whatever, and Arvis is famously a little finicky, it's not a hundred
Yeah.
percent
Yeah.
robust. It might not catch it, so you're like, wait, where's my map? Uh,
Okay.
so basically, that I'm pretty sure that's the reason why, because you just only did it
Yeah. Even I
once.
felt like maybe the synchronization is not like properly happening. The way these both of the nodes are receiving the map are different. So
Yeah,
if I
like it
set
won't
them,
it won't
yeah.
republish based on a new node joining,
Ye-
like Arvis joining the network. It won't like republish it. So you have to
Yeah.
you have to be careful with that. Yes, I'm sure you can
Hmm.
do a republisher or something. You can create a
Yeah.
node, for example, to make sure that you
Oh
catch it
yeah.
once and then that one publish it, every minute or whatever, just in case. But yeah,
Yeah.
that's the reason why.
Okay.
Awesome. Well,
Yeah.
very, very nice to chat with you. And it was very nice project, Sachi. So congratulations. Very nice
Thank
project. All right.
thank you, and also thank you for creating the course. It was really helpful for me,
No problem.
and I'm glad to share my presentation.
I'm glad to see that you took something out of it and learned all this about autonomous navigation.
Thank
So
you.
let me just switch back to my screen here. And yes, guys, this is what you can do when you take one of our courses, is to come and present what you've learned in this project implemented on real robots. This is very useful for your skills and to showcase what you've took from our course. And that way we can confirm it and offer you guys one of our certificates that mean a lot to us. So I invite everyone to do what Sachi has done here and come present the project if you have done our course. So that's it for us, guys. We'll see you next time for our next presentation. Bye-bye.